Hi, I'm Eunho Choi, a graduate student at the Department of Bio and Brain Engineering at KAIST. I'm working in Dr. Woo Jung-shin's laboratory to develop a new platform to test the efficacy and safety of bacterial therapeutics to potentially replace and reduce animal testing. The overarching goal of my IFER-funded research is to establish a pipeline that can be used to evaluate the safety and therapeutic efficacy of engineered bacteria in vitro without using animals. Currently, most microbiota-related research relies on animal models because there isn't an in vitro model that allows for long-term culture of bacteria with human cells. But animal models have significant differences in physiology, structure, microbial population, and colonization compared with humans. This can lead to different outcomes in humans, resulting in unpredictable adverse effects and less efficacy. In the case of genetically engineered bacteria, a stricter evaluation is necessary. That's where human colony chip technology comes in. This system includes all the essential cells that make up the intestinal environment, including three-dimensional epithelium in a microfluidic device. It allows researchers to adjust the microenvironment with the immune cells, vascular cells, and more, making it ideal for testing therapeutics. It can even replicate mechanical cues like flow and repetitive contraction and expansion. Most importantly, it uses human cells so it can reliably predict what might happen at the cellular and genetic level if the treatment is applied to humans. My bacterial therapeutic is designed to specifically bind to GBS membrane proteins. It will draw the GBS out toward the gut lumen where it can be washed away by gut's natural flow. I will achieve this by utilizing human epithelial cell membrane proteins known to specifically bind with GBS proteins. In a GBS infection model, I will evaluate the therapeutic efficacy of my engineered bacteria. For instance, a specific capture and removal of GBS and decreased immune reactions will be assessed. To confirm safety, I will use a normal colony chip and observe whether any aberrant immune responses occur upon the introduction of engineered bacteria. We are very optimistic that we will be able to set up an ideal in vitro platform for testing new bacterial therapeutics. This will greatly expand the pipeline for developing new bacterial treatment while significantly reducing the reliance on animal models.